Hey, Chem20 IB. This is just a real short video reminding everybody what mole ratio is, because tomorrow we're going to start stoichiometry proper and we need to have everybody on the same page about what mole ratio is. Most of you will get this really quick. I think it's pretty easy. So if we had a reaction, and luckily in stoichiometry in Chem20 IB, we're only using the molecular formula or the non-ionic formula. We have to make sure it's balanced and we have all proper states. So it looks like I need a 2 there and a 3 there. So now we're balanced. Now, in stoichiometry to start with, what we're going to be doing is comparing two entities, two elements or two compounds. And we have to understand that between those, there is a ratio of moles when we've balanced it. So if I was comparing nitrogen to ammonia, those two entities, the ratio between the two is 1 mole of nitrogen and 2 moles of ammonia. That's the mole ratio. Now, we're going to be writing the ratio as a fraction, but you could also say, you have 1 nitrogen for every 2 ammonia. That's basically what that means. That's what mole ratio is. So tomorrow when I talk about writing down the ratio between two of the things we're comparing, we're not comparing hydrogen, so that's not even in this question. We're going to write down, there's no number there, but we're going to assume that's 1. Okay, and this is balanced for 2. We're going to write that down as a fraction. So that's going to come up again and again and again and again. This entire unit, every math problem uses mole ratio. Okay, so let's try another one. Let's say we had C3H8 gas plus oxygen. In hydrocarbon combustion, we get carbon dioxide gas and hydrogen gas. Okay, balances 3, 4, we got 6 oxygens plus another 4 is 10, 5. Okay, so if I was comparing the oxygen to carbon dioxide, what would be my mole ratio? Well, the mole ratio would be 5 moles of oxygen over 3 moles of carbon dioxide. Okay, that's only if I'm comparing those two. Now, if that changes, let's say I was comparing these two, then my ratio would be different. In stoichiometry tomorrow, we're going to be comparing one substance to another substance, and we're always going to be having to use this mole ratio. Okay, so my mole ratio is 1 mole of the red, the red comparison of C3H8 gas per 4 moles of water gas. Okay. Now you might be saying, what if we tried to compare 3? You can't. You absolutely can't. You can't have 3. You can't have like something like this. You can't compare all 4 at once and have like a quadruple deck thing. That will never happen. We will get to some very hard problems in a week or so where we have to compare 2 different pairs. We might be like, okay, we're going to compare these 2, and then we're going to compare this to this one, but you can only do it in 2s. Now, if you just came into this video and you were looking at all these lines, you'd lose your mind. But just going back, mole ratio is the comparison of 2 entities, and it doesn't matter. You'll see when we start stoichiometry, you might be like, how do you know which one goes on top? It doesn't matter, because this ratio can be flipped to suit our needs using unit analysis. So if you decide to write the ratio 2 mole of ammonia over NH3 over 1 mole of nitrogen, that's correct. Both of those are fine. It does not matter, but it will matter to have them in the right order when we start doing the math tomorrow. Okay, so that's just a real quick recap of mole ratio. You will have the rest of today to work on the Floop assignment, so there's nothing new aside from this video. And then we are starting stoichiometry tomorrow.